Okay, let's now look at worksheet 5, the last one. Question number 1. A coin has 60% chance to land on head if it's freely tossed. Let x be the number of heads on which it lands in 4 tosses. Is this a binomial distribution? Then we just need to verify 4 conditions for some experiment to be a binomial experiment. So first one, fixed n. Freely tosses and x be the number of heads on which it lands in 4 tosses. So that tells us n equals 4. It is fixed. So one check. And the second one, we're going to check whether we have the 2 outcomes. So head or tail, so that is checked. Number 3, independent. The first one and second one, no influence, so independent verified. 4, probability of success remain the same. A coin has 60% chance, so that's 0.6, and it is remain the same. And yes, it's a binomial distribution. So then we're gonna set up the probability distribution and find the mean standard deviation of this one. So x, probability of x. So x gonna be the number of heads. So we could have 0, so all 4 tails, that's 0 head. And 1 head, 2 heads, 3, and 4. So 0 to n, that's the possible outcomes for a binomial setup, 0 to 4. And then we have all the probabilities. We need to fill in all those probabilities. And then we want to find the mean and standard deviation. So we don't have to know the entire probabilities for binomial setup, because expected value, which is the mean, that is n times p for a binomial. So then n is 4, p is 0.6, then the expectation is 2.4, or the mean is 2.4. And standard deviation of x, which is square root of the variance, which is np 1 minus p. The square root of 4 times 0.6 times 0.4. So that gives us square root of 0.96. So that is 0.9798. And for those probabilities, we can just look at the binomial table. So this is the table, and we need to have n equals 4, and probability is 0.6. And this block is the probability distribution for our example here. So we just need to write down x can take 0, 1, 2, 3, 4. Probability is 0.6. So this is 0.026 and 0.154, 0.346, 0.346, and then 0.13. Then we got question number 2 solved. And for those probabilities, you can also use this formula. So n choose r, p to the probability of, I think we use x, and 1 minus p to the probability minus x. Plug in to this formula, you can also get the probabilities. And I want to calculate the following probabilities using the binomial table. So x more than 4. This one we don't have to check because x can only take 0, 1, 2, 3, 4. More than 4, nothing, so 0. And probability of x more than or equals 1. So that is probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3 plus probability of x equals 4. 1, 2, 3, 4. We want to look at these terms add up together. Actually, it's just 1 minus probability of x equals 0. So 1 minus 0.026. Then we got 0.974. And at probability of x equals 3, we can just check it, 0.346. And let's calculate it using the formula to verify. So n is 4, right? Choose x equals 3. 0.6 to the power of x. 0.4, 1 minus p, right? To the power of 4 minus 3, which is 1. And that's 4 choose 3 is same as 4 choose 1, and 4 choose 1 is just 4. So 4 times 0.6 to the power of 3 times 0.4. So that gives us 1.6 times 0.6 to the power of 3. So 0.3456. And that is the probability. And this is from the table. They're the same. Probability of x smaller than or equals 1. Probability of x equals 0 plus probability of x equals 1. Just when you look at something combined together, it's just look at the requirement and then discrete it, write in a discrete format what terms add up together to get this one, and then you can figure out. Probability of x equals 0.026. Probability of x equals 1.154. So simply do the addition. So that'll give us 0.18. And 1, 2, 3 inclusive. So probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3. So 1, 2, 3, 0.154 plus 0.346 and 0.346. So that is 0.846. So we got that probability as well. So that is the binomial question. And then number 4 is a regular discrete distribution. Find the standard deviation of the following probability distribution, the random variable x. Then we just need to figure out what we put here first. Then that is 1 minus 0.5 minus 0.2 minus 0.1. Because to make sure this is a discrete distribution, that means all the probabilities add up together equals 1. So you're lacking 1, then just use the rest to get the value there. So we got 0.7, 0.8, so that is 0.2. And then we can get the expected value of x, which is the mean. So that is sum of x times probability of x. So 1 times 0.2 plus 2 times 0.5 plus 3 plus 5 times 0.2 plus 10 times 0.1. So 0.2 plus 1 plus 1 plus 1. So that's 3.2. And then we need to know expected value of x squared. So that is 1 times 0.2 plus 4 times 0.5 plus 25 times 0.2 and plus 100 times 0.1. So this is all x squared. So that gives us what? Let's see. So we have 0.2 plus 2 plus 5 plus 10. So 17.2. Then the standard deviation of x is square root of variance of x. It's going to be square root of expected value of x squared minus expected value of x and then squared. So that's going to be square root of 17.2 minus 3.2 squared. So let's see what it is. 2.638. We finished this worksheet 5 as well for the discrete distribution. And that's all for the extra video lecture for the worksheets. And let me know if you have any questions. Thanks.